Oh hi, didn't see you there. Welcome to South Downs College Engineering and Automotive Studies Department. Today, we'll be looking at CNC machining. But before we get there, we're going to have to go through some PPE so you can get yourself in the workshop. What are you going to need to wear for PPE? Well, first off, you're going to need some steel cap boots. The second thing you're going to need is a pair of safety goggles. And the third thing you're going to need is some G white overalls like this. Do the effects. Because I've seen it. Wear their PPE. And you weren't there, man. You weren't there. God. Hi guys. Today I'm going to tell you about a drill. This drill. Not specifically this drill, because this is a manual drill. We're talking about CNC drills today.
Hoorah, soldier!
CNC.
Hoorah!
Yo. And what we're going to talk about is the axes, the components, and it's a little bit of description. Might throw some oregano in there. Anyway, man, I'm talking about my dinner again. Okay, what we're going to do. Axes. Drills work on a Z-axis, which is the depth of the cut. This is the Z-axis, okay? Then we've got the X-axis, which is going along. So we're going to move along like this. And then we're going to go for the Y-axis, which is like this. It's like that, which is got the X-axis there. And we've got the Y-axis, which is kind of like going from me to you. Yeah? We got this. We got this. Typical components can be PCB boards, anything that's really drilled with multiple drill holes that need to be geometrically correct. You heard that from me. Okay, once you've got those holes, it's smooth sailing for you. For you. For everyone. Especially me. Because I'm up in this hell.
Word!
Word!
To your mother!
Hi there. This is the Concept Turn 250. She's a turning center. And you might ask what a turning center is. Well, basically it's a lathe. But the key to a turning center is that it's computer numerically controlled. Top of the range models often include functions such as milling and drilling. But every model has the functions of a normal lathe, such as boring, parting off, turning, making tapers, and knurling. Parts that can be made on it, well, that's pretty much anything from satellites in the sky to submarine gears under the ground. There's a lot. Even mallet handles. I made one last year. It was intense. I know about these things. The thing that's different with a lathe, you see, is the fact that the Z-axis sits horizontal, because the Z always follows the tool. I'm going to show you what that looks like here. So instead of being a vertical Z-axis, we got one there, it's horizontal. We've got the Y there, and the X there. I hope I got that the right way around. Thank you. Yeah, hi Graham, how you doing? Oh, hi. Didn't see you there. Remember my friend Emil? Yeah, man. We were real tight. And let me tell you a little bit about my machine mill right here. Little Millie Boom. Yeah. Anyway, it's 3 axes. And that's the X. The Y. And the Z, man. Yeah. It's my friend's code. Showing you on a little diagram here. What happens is the X and the Y will be used to go this way and that way. Then we've got the Z-axis, which will go up and down, kind of like the cutting tools motion. So that's the designation, as you can see here. Up and down. The red means pain. Pain means cutting. Yeah. And let me tell you a few little components that might be made with this bad boy. Anything that can be machined is machined on a mill. Let me tell you why. Because it's got to kick ass. Yeah. It's not messing with pants.
Hi, I'm going to talk about CNC rotors. What are those, you might ask?
What are those?
It's computer numeric controlled, and it's a router. You can use routers for wood, composites, aluminium, steel, plastics, and foam. A CNC router performs many tasks that carpentry shop machines use, such as the panel saw, the spindle molder, and boring machines. Very similar to a mill, but uses different tools and is intended for carving out the shape instead of shaping the shape. Now, the spindle that holds the tool in place works on the Z-axis, and the X and Y are used to navigate around the horizontal planes, if you know what I mean. Examples of typical components would be chairs, doorways, guitars. That's a CNC router.
Oh, hi, didn't see you. Just got me doing some math. I've got the pleasure of talking to you about machine centers. What are machine centers, you ask? It's a good question. Well, machine centers are any CNC tooling machine that changes its own tools and clamps the workpiece in place. Now, a unique feature about these machine centers is the fact that it's the tool that rotates and not the workpiece. Let's have a quick look over here at this one. As you can see inside here, there are lots of different tools to be used on the one bar that is sat in the lathe stock. This will be classified as a machining tool center. Now, let's get down to the axes, a very important part. The thing is with machining tool centers, there's so many different types. You can have milling, you can have drilling, you can have anything else that rhymes with that. It's very open and wide. Filling. But vertical machine centers, that is to say, where the milling machine tool is parallel to the z-axis, as it always is, but it's vertical, are normally considered in general purpose in industry for more precision, whereas horizontal, such as a lathe, is considered for speed, so that's something you would use in mass production. But as I said earlier, it is key to note that the z-axis always is parallel to the machine tool. If we're on a lathe, the z-axis is there. If we're on a milling machine, the z-axis is there. Typical parts, well, there's many things from crankshafts to aircraft parts to pretty much anything you find around and about. But that's the truth, that is the word, that is the gospel, and I preached it, you heard it, and you got it here live on NRBC Network.